All right, we got a ton to cover in this video, and I know y'all got the attention spans of lab rats on crack. So what we're gonna do is we're gonna talk about it at a really high level, and then you let me know down in the comments which parts you want to see me go into more detail on. So let's cut the crap and get right to it. So remember that DevOps is not who does the stuff, but how we do the stuff, right? And that's why I'm making these videos targeted towards you as developers, because ultimately y'all are the ones who need to know how. You can't just rely on somebody else to do it for a couple of reasons. One, you've got to provide them the guidance of how you'd like it done. And two, there's just an overall shortage of people with DevOps skills. And so there's not really anyone to be the who except for you, without turning this into a bunch of Dr. Seuss crap. With that said, you still got to know what to do though, right? I mean, it's all cool to have all these high-level conceptual talks, but ultimately you got to put your hands on the keyboard and start typing to make shit happen. So that's kind of what we're going to talk about today at a really high level. And the overall goal of this is, I know you can build an app and I know you can get it up and running, whether that's in Heroku or AWS, on EC2 or on a Lambda. I know you can do all of that. The part that I want to focus on is helping you get that from deploying that and serving one customer to serving 1 million customers without bankrupting your company because you're getting $150,000 a month AWS bills. We're going to start with the beginning, and we're starting there for two reasons really. One, because it's at the top of my list over here, and two, because it's something that I'm pretty sure you're already familiar with, and that's the development lifecycle. Because I know that you're out there writing code, and you know, it kind of follows, or it probably follows a pattern, something along the lines of you create a new branch, you do your changes, you open up a pull request, that runs a test suite, somebody reviews both the test suite results and the code changes that you made, and then you merge that into your, whatever you consider your protected branch to be, whether it's called master or production or staging or however your workflow looks, and then ultimately you deploy that to your production environment, right? So that's all kind of wrapped up in this concept called CI/CD, which is actually a couple of different things, but we tend to lump it under one cool acronym because actually I don't know why, and it doesn't matter. The CI part though stands for continuous integration, and the part that really refers to is frequently taking those code changes that you make and getting them into your master branch, whether that's completely automated, which is rare, or through a process of peer reviews where you make a peer review or make a pull request and somebody reviews that code and merges it in. And the reason that's such a novel concept is because if you go way back in time to when I first started doing this decades ago, you would just take your code and you would have it out for months at a time, and once every 6 months or once every 8 months you would go through the process of merging that into the main branch if you actually used version control at all. And as you can imagine, it was pure hell. So a lot of people are excited about continuous integration, rightly so. If you weren't aware of the pain that it was there to solve, it may be a little harder to get excited about it, so just fake it. Humor me. All right, the next part of CI/CD is the CD part, and it can actually kind of be broken down into two different pieces itself, into continuous delivery and continuous deployment. So continuous delivery is sort of at the tail end of that continuous integration process, and that's the actual act of making your code ready to go to production. Not actually putting it into production, but making sure that everything, all the changes are merged in, and that you have this branch that you're ready to deploy at any time. The continuous deployment part is the other end of that, the tail end of that, and that's the process of actually deploying your code to production. And so there's, continuous deployment kind of implies that it happens automatically, which may or may not be the case. There's certain environments where You just, if somebody approves a pull request, hell yeah, ship that bitch. But there's other environments where you may want to have a little more granularity and a little more control and a little more orchestration around that. And either one of those are totally fine. It's whatever works best for your business. The next part of this that I want to talk about is the architecture. And this is really, think about it as the place that your applications live and call home, whether that's AWS, Azure, Heroku, it doesn't matter. The part that I want to bring up about this is if you're using Heroku, you've kind of got limited options here. You just kind of got to go with the service that they provide you, which is, if that's working for you, go for it. But the larger your application gets, the more that you're probably going to end up in an environment like AWS or Azure or Google or even in your own data center. And so this is the part where I want to focus on, where infrastructure as code is king. Because every time that someone in your environment builds a piece of infrastructure using the point and click GUI, where they click and say, oh, I want one of these, and we'll give it this name or whatever, however that process works. Every time that happens, you should consider that a failure in your company, because you can't reproduce the steps that they took. Now, you might think that you can, and you might get pretty close, but you're always guessing unless you happen to, I don't know, like screen capture whoever was doing it, and don't do that. That's a shitty idea. Don't do that. Instead, do infrastructure as code. And what infrastructure as code means is you deploy those resources using the same deployment mechanism that you use to deploy your application code. And so that means if you have, 3 Docker containers behind a load balancer with an SSL cert talking to a specific database, it's all documented in code. And so just like the changes you make to your application code, if someone needs to make a change to it, they create a branch, they open a pull request, somebody reviews it, you merge that in, you do the whole CI/CD thing, and everything's wonderful, because then you know exactly what state your infrastructure should be in. And if at any time it turns out that that's not the state that it's in, you just say, fuck it, and run your deployment script, and it makes it that way. So you don't have to try to figure out who did what or when they did it or anything. So the third thing we're going to talk about is security. And just for reference, these aren't in any particular order. That's just the way they came out of my head. But security, right? And that's a bunch of different areas. That's client security. How do your clients or customers or whatever name you have for them, how do they access your application? Is it through username and passwords? Is it through an SSO provider? Do they have API keys? How do you ensure that your users or your customers are who they say they are? All of that's done in client security. But you've also got network security too, right? Because you've got a public-facing, most commonly a public-facing service. And public-facing means that attackers are just going to be beating on it all day long. So what are you exposing to them? What tools are you giving, or what assets are you allowing them to grab and shake to find vulnerability in your system? And that's important, right? Obviously, if you have a web application, you have to have port 443 open for web traffic. No way around that. But what else do you have open? Do you have other things that shouldn't be open? Do you have a mail service port open? Do you have port 80 open for HTTP traffic? Can you close that completely? Or if you can't close it completely, can you automatically redirect it to the HTTPS? Different things like that. And then the other assets in your environment, in your infrastructure. Are you operating everything in a VPC? And that ensures that everything is happening on an internal network and not publicly exposed. Is your database publicly exposed? I know I can think of several data analytics providers who require you to have publicly exposed database ports, which means anyone can try and access your database. Granted, they need a username and password, but if your database is up and running for years. So that's network security. The third component of this is employee security. You're going to go through employees throughout the course of your business. Different people on your team. You're going to have new team members come on. You're going to have team members go to other teams. Team members move on with their career. Once they do that, how do you maintain the security around those user accounts? You have to be able to ensure that only the people who currently need access to your environment have access to it. So making sure that they're following, like rotating password policies, using two-factor authentication, rotating their IAM keys if they're in AWS, and securing their accounts once they no longer need access. And the final part that wraps all of that stuff up in security is the scan and audit process, because that's going to reveal a lot of the things that you overlooked whenever you're putting all of this together. As we talked about it, you probably got some ideas that were coming in, but that's only the tip of the iceberg. The real key to security is identifying the vulnerabilities that you didn't know you had, and the tool to do that is scans and audits. All right, the next one on the list, number 4 out of 5, is one that I feel like gets overlooked a lot whenever we have developers moving into operations type roles, and that's storage. So you've got storage for your databases, different things like that. You've also got file storage for your application servers, and you've got log storage where you're writing out application logs. What do you do with those? And the big key to those, like you'll get most of those right, the big key though is backups. Are you backing it up? Are you backing up the data that you need to back up? Backing up your database and backing up your log files so that if you need them, you can go restore from that, which is the second part of that. Are you restoring on a regular basis and testing that your backups are valid? Because I've been in many scenarios where we had a shitload of backups and it turned out none of them were good. And then the final piece of that is the retention policy. If you're making daily backups or every hour backups, whatever the case is for your business, probably not going to want to keep those indefinitely because it's just going to consume huge amounts of space, which drive up your overall operating costs. So what's your retention policy? Do you keep daily backups for the last 30 days and then keep weekly backups for the last 6 months and then monthly backups for the last 3 years, or something like that? What is that retention policy and how do you enforce that? And the final piece, which I think is the one that people go to whenever they think about DevOps first, is the ops portion of that. How do we scale our application when we have incoming additional traffic? How do we scale up to meet that capacity? And how do we know what our capacity requirements are? Where are our places where we need to scale up? If we have a microservices type environment, do we just say fuck it and scale all of them up, or do we have different ways of seeing, like if we get this increase in traffic coming in, we know we're going to see it limiting on this part of the microservice first, so we'll focus on scaling that out and then branch out from there. It's all stuff that you will learn through load testing your application. Another component of ops is the monitoring. All of your auto scaling is triggered off of monitoring. So if you're not monitoring, you can't really do auto scaling. Another key component or another key need for that is for troubleshooting. If you get an incident that comes in, if you have issues that you're trying to resolve, monitoring is a huge piece in identifying what's the problem here and what are we trying to solve. And along with monitoring, you need logging. So you're monitoring to see like the numeric performance of your system, and then logging is like the novel that goes along with that to tell you the details of the story. Both of those combined together make up or set the stage for our alerting system so that we're the first ones that get notified when there's a problem, because you're going to have problems, you're going to have outages, you're going to have incidents. The worst way to enter into an incident is because your customers are telling you that your shit's down. So you want your alerting system to be the first one to know that there's a problem And then that goes right into your on-call rotation, where you have you and your teammates on call doing a rotation so that no one's getting beat up all the time. And your alerting system triggers whoever's on call, they respond to it, and your on-call rotation should have some tiers of escalations to that, so that if, for whatever reason, for whatever unfortunate reason, your first responder can't respond to that page, that after X number of minutes, it escalates up to someone else so that that call gets responded, and then you can also check in on your teammate and make sure that they're okay at the same time. The big parts of it that we talked about here were the development lifecycle, the architecture, security, storage, and ops. So I'll put all of these in a chapter so you can jump around between them, and then let me know in the comments which ones you want to go deeper into. And while you're down there putting the stuff in the comments, hit the subscribe button too, so that you will be notified whenever I release new videos. All right, that's it. I'll see y'all.